The incandescent light bulb is the most simple and oldest type of light bulb discussed in this video. It's made up of three key parts: the glass bulb, the filament, and the electrical contacts. The glass bulb provides an oxygen-less environment for the internal electronics to work. But to get a closer look at how they work, let's remove the bulb and zoom in. The filament is held in the middle of the bulb by two wires, a positive and a neutral wire. These wires allow AC power to flow through the filament. In the animation here, the electrons are in blue. If we zoom inside the filament material, you can see the electrons moving through. As the electrons move through, they bump into the atoms of the wire, transferring their energy to them. The filament used in incandescent light bulbs is made of tungsten. This is because it has a high melting point and has high electrical resistance. What is electrical resistance and why is it important for this purpose? Electrical resistance is how hard it is for electrons to move through a wire. You can see in the wire that electrons have to avoid tungsten atoms to make it through. If they hit the atoms, they transfer their energy as heat, making the wire hotter. When the filament gets hot enough, it converts some of the heat energy into light. This is a very inefficient way of making light, as 80% of the input energy is wasted as heat. Why does the filament not burn? The filament needs oxygen to burn. By replacing air with argon gas in the bulb, it stops oxygen from getting to the filament unless the bulb breaks. Because incandescent bulbs are inefficient, they are being phased out. This was done by the EU Commission Regulation 244 in 2009. This banned the sale of new 100-watt incandescent bulbs in 2009, followed by 60 and 40-watt bulbs in 2011 and 12 respectively. The legislation recommended replacing them with compact fluorescent lamps. Compact fluorescent bulbs are made up of three key parts: the glass bulb, the lighting ballast, and the electrical contacts. I'm not going to cover how the lighting ballast works in this video. I will make a video specifically on this topic in the future. But let's zoom in to see how the bulb produces light. Compact fluorescent bulbs are filled with a mixture of argon and mercury vapor. They create light in a two-stage process. It is easier to explain using a cross-section. When electrons are passed through the gas, it adds energy to the atoms. They then release this energy as UV light photons. This is the wrong wavelength for a standard light bulb. So to fix this, they coat the inside of the bulb with a phosphor. A common misconception is that a phosphor is the same as phosphorus. A phosphor is a chemical compound that emits light when it is exposed to light of a different wavelength. The change to compact fluorescent lamps wasn't without controversy. Because they use the toxic metal mercury and 80% of compact fluorescent lamps are not recycled at the end of their life, they are not the best choice. Luckily, there is one more option: LED. LED, or light emitting diode, are the latest development. As with compact fluorescent lamps, I will explain the electronics in a separate video. If we remove the diffuser, we can see the individual components mounted to a PCB in the bulb. To see how they work, I have created an animated cross-section of an LED. This is a very simplified version of the process. LEDs are made of two materials. The one in red here has a positive bias, meaning it wants more electrons. The blue section is negative bias, meaning that it has too many electrons. And in between them is the depletion region, where the two materials meet. By adding more electrons to the blue negative material, it gains enough charge to move an electron over the depletion region to the positive material. The blue electrons have more energy that is missing from the red atom, so the excess energy is turned into light. LED lights are as efficient as compact fluorescent bulbs, but without the risk from mercury waste. This makes them a better choice when replacing your old bulbs. Thank you for watching. If you've enjoyed this video, please let me know by giving me a like, and if you have a future topic that you'd like me to cover, please add it in the comments.